Hello everyone, I am Professor SHRUTI DIXIT, Assistant Professor in Electronics and Communication Department, Sagar Institute of Research and Technology, Bhopal. This college is under SAGE Group. Today we will discuss about the subject microprocessor and its applications, EC-501, the architecture part of this 16-bit microprocessor, which is 8086. In the previous lecture, we have taken just a brief overview of the subject, its syllabus, its course outcomes, learning outcomes, course objectives. Here we will discuss about its important features and architecture of this 8086 microprocessor. It is available in three versions: 8086 5 megahertz, 80862 8 megahertz, 80861 10 megahertz, and it consists of 29,000 transistors. It was launched in 1978. It is a 16-bit microprocessor, and it is the biggest advantage is speed is the biggest advantage over this 8085, which is 8-bit microprocessor, and it is available in 40-pin dual-in package. 16-bit data bus, 20-bit address bus, and 1 MB of memory, and it has more than 20,000 instructions, and it supports multiplication and division. These are the few more features of 8086. 16. It is a 16-bit microprocessor. It requires plus 5-volt power supply. It is available in 40-pin dual-in line package, 20-bit address bus, 20-bit address bus, and 16-bit data bus, and it can support up to 64K input-output ports, and it provides 16 and 14-bit internal register, and it has multiplex address and data bus AD0 to AD15 and A16 to A19. It requires single phase clock with 33% duty cycle to provide internal timings. As we have already discussed this feature, it is designed in 2 modes, minimum mode and maximum mode, and it prefetches 6 instruction bytes from the memory queue in order to speed up the instruction execution. So these are the silent features of 8086 microprocessor. We will discuss the internal architecture of 8086 microprocessor. The whole architecture is divided into 2 parts, BIU and EU. BIU is bus interface unit and EU is the execution unit. So we will discuss one by one. This BIU handles all transactions of data and addresses on the buses for execution unit. BIU performs all bus operations such as instruction fetching, reading and writing operands for memory and calculating the addresses of the memory operands. The instruction bytes are transferred to the instruction queue. The execution unit executes instruction from the instruction stream byte. The main function of the BIU, in short, the main function of the BIU is to fetching the address and the data, and the execution is to decoding and execution part will be handled by this execution unit. This BIU consists of instruction queue, segment registers, instruction pointer, address adder, and execution unit contains control circuitry, instruction decoder, arithmetic logic unit, pointer and index registers, and flag registers. So first of all, we will discuss about the bus interface unit. Bus interface unit consists of 6-byte instruction queue. This is the 6-byte instruction queue, segment registers, instruction pointer, and the address summing block. This is the address summing block. The BIU uses a mechanism known as instruction stream queue to improve the pipeline architecture, and this queue permits prefetching of data up to 6 bytes of instruction code, and whenever the queue of the BIU is not full, it has room for at least 2 more bytes. At the same time, the execution unit is not requesting it to read or write operands from the memory. The BIO is free to look ahead in the program by prefetching the next sequential instructions. This is the main function of the queue. The complete memory is divided into 4 parts: core segment, data segment, extra segment, and stack segment. The segmented memory, the memory in 8086 is organized as segmented memory. The CPU is able to address 1 megabyte of memory, and the complete physically available memory may be divided into number of logical segments. The 16-bit contents of the segment register in BIU actually point to the starting location of a particular segment, and each having capacity of 64 KB. The size of each segment is 64 KB, and a segment may be located anywhere in the memory. Each of these segments can be used for a specific function. The 4 segments are code, data, extra, and stack segments. Core segment is used for storing the instructions. The stack segment is used as stack, and it is used to store the return addresses. And the data and extra segments are used for storing the data byte. The advantages of segmentation is to increase the execution speed of the computer system so that the processor can be able to fetch and execute the data from memory easily and fastly. Multitasking becomes easy, and it permits a program or its data to be put in different areas of memory each time the program is executed. Segment register, 4 segment registers are there: code segment register, data segment register, extra segment register, and stack segment register. All are 16-bit registers, and each of the segment registers store the upper 16-bit address of the starting address of the corresponding segment. Now we will talk about the execution unit. Execution unit decodes the instruction. These are the 3 important functions of the execution unit. Decodes the instructions fetched by the BIU, then generate the control signals and executes the instruction. The main parts are control circuitry, instruction coder, and arithmetic logic unit. The general purpose register, 16-bit general purpose registers are there: 4 accumulator, base, count, and data, AX, BX, CX, and DX. Accumulator register, base register, count register, and data register. 2 pointer registers are there: stack pointer and base pointer, and 2 index registers: source index and destination index. These AX, BX, CX, and DX are further divided into 2 parts: AH, AL, BH, BL, CH, CL, and DH, DL. AH higher byte and L stands for lower byte. The function of this AX is to word multiply, word divide, word input output. AL byte multiply, byte divide. H byte multiply and byte divide. BX store address information. CX string operation. CL variable shift and rotate. DX word multiply, word divide, indirect input output. This is the function of the AX register. It holds operands and results during multiplication and division. All input output data transfers using input and in and out instructions are A register. It functions accumulated during string operations. And these are the examples are given. We will discuss these examples during the programming part. BX register is used to hold the memory addresses, offset address in indirect addressing modes. CX register for count for instructions like loop, rotate, shift, and string operations. DX register is used to hold 32-bit values during multiplication and divisions, and it is used to hold the address of the input-output port in indirect input-output addressing mode. Pointer and index register is used to keep the offset addresses used in various forms of memory addressing. In case of a stack pointer and base pointer, the default reference to form physical address is the stack segment. The index register and BX generally default to the data segment. Stack pointer to access the stack segment, and base pointer to access the other segments. Source index register. Is required for some string operations. Both are used for string operations. The stack index register points to the memory locations in the data segment, which is addressed by the DS register. And destination index register points to memory location which is addressed by the ES register. Here DS register and here extra segment register. And SI and DI register may also be used to access data stored in arrays. Flag register, a flag is a flip-flop which indicates some conditions produced by the execution of the instruction or control certain operations of the execution unit. 16-bit flag register, 9 of the 16 are active flags and 7 are undefined. 6 flags indicate some conditions, status flags, and 3 control flags. These are the U stands for unused, and these are the carry flag, parity, auxiliary AF, zero flag ZF, sign flag, interrupt flag, direction flag, and overflow flag. These are the functions of these flag registers are given. Holds the carry after the addition or borrow after subtraction. Parity, if odd parity is there, the value of PF will be 0. If even parity is, the PF is 1. Auxiliary flag holds the carry after addition or borrow after subtraction between the bit positions 3 and 4 of the result. Zero flag shows the arithmetic or logic operation. If result is 0, then Z is equals to 1. If result is not 0, then the value is C. Sign flag holds the sign of the result after an arithmetic logic instruction. Trap flag, it is the control. Trap flag, interrupt flag, and direction are the 3 control flags. It enables the trapping through an on-chip debugging feature. It controls the operation of the interrupt request. When the interrupt pin is enabled, then value of I is equals to 1. When the interrupt is disabled, the I is equals to 0. It selects direction flag. It selects either the increment or decrement mode of the DI during the string instructions. And overflow occurs when the signed numbers are added or subtracted. And overflow indicates the result has exceeded the capacity of the machine. So this is all about the architecture of the 8086 microprocessor. In this lecture, we have discussed the silent features of the 8086 microprocessor and complete architecture of this 8086. It is divided into 2 parts, execution unit and bus interface unit. And we have discussed the different parts of the functions and parts of this execution unit and bus interface unit. Thank you so much.